All right.
I don't know where she lives. She's around here somewhere. I'm going to find her. Okay, guys, anybody have questions from homework? Nobody? Is that all right? I'm an optimistic fool. I know that there are several people who are very behind in homework. So let me give you, if you are here right now, let me tell you, your main priority is to do the homework related to the next assessment. And what is the quiz going to be on this Thursday?
You said 19, 21, and 22.
Yeah, maybe 2-3. I don't know. Maybe not 2-3. We'll see. Cool. Cool. So wherever you are, wherever you are in the homework, if I got a quiz coming up and I know what sections it's covering, I'm going to stop and I'm going to move and I'm going to do the stuff that's related to the quiz. I mean, that only makes sense. I hate it when someone says, I suck so bad on the quiz, Jeff, because I didn't do any of those sections because I'm back in chapter 1. I'm like, holy shit. Don't do that to yourself.
Yeah, I'm frustrated right now because I'm like, I tend to want to be perfect in everything, so I can't. When I get disorganized, it just frustrates me even more. And
yeah.
I agree with you.
So this is for anybody in that situation. There are several people in that situation, so
right.
It's good to know priorities.
Yes.
Let me see. Some more people logged in. Does anyone have questions? Okay. I'm going to try not to worry too much about that. Yeah, so don't take me wrong. So I am a little bit coming down on you if you're very far behind in homework. But if you are behind in homework, understand what takes priority, right? The first priority is whatever's coming up soon on a quiz. The second priority is homework you haven't done yet. Go back and do it. The third priority is homework corrections, right? That's your last priority because when are homework corrections due?
Before the final.
Yeah, by the day of the final. Final is cumulative, so I actually don't really care when you do those because whatever homework corrections you do is going to help you for the final anyway. I understand. Yeah, I don't understand. Are there not many teachers that post videos of lectures to YouTube?
They sometimes take it down.
Take it down?
My
I don't understand.
teacher only has it up for like a day or two and then they take it down.
On YouTube or on Canvas?
I think on Canvas.
Oh, okay. YouTube, I mean, I don't think it's ever going to go away. I don't think it's going to get banned like TikTok or something. I've got videos on there from 2010 that I did lectures. I mean, anyway, sorry. It just doesn't make sense to me. It's just really silly. And the videos help me out too. Don't get me wrong. If it's been a while since I taught something, I'll say, oh, I taught it in 2015. Let me go look at that video on the first day. Oh yeah, I got that worksheet. Good Lord, it helps. Or like last week, did I say there was going to be a quiz? Let me look at my video. Oh yeah, I did. Anyway, sorry.
I guess it would make sense to record, like have like some type of, to record the class sessions online that we have with you. You know, in case we have a question, we don't have to always continue.
Yeah, exactly. That's why I do it. And most teachers are using Zoom, and Zoom will automatically record shit. So it just, anyway, I'll stop.
All right.
So no questions from homework, anybody? Is that it? All the questions I talked about before class started? Everybody else is fine. Everybody else is cool. Okay, all right. Let's see. So I want to get back into where we left off then, if there's no questions. And we left off in section 2.3 with our South Park for some reason. And this section is going to be all about, I mean, you can always read up here at the beginning, area volume. So we did a little bit of that. We got to get a little deeper. So we talked mostly about units so far. And we have talked about that before a little bit. Then we're going to have formulas to calculate the areas and the volumes. And then for some reason they stuck in here, way in section 2.3, important skills for college students to have. I kind of enjoy that. That should probably have been in section 1.1, but oh well, you know, whenever they can throw it in, that's great. So I think we made it to here, if I remember correctly. And we talked about the formula. Can somebody remember the formula for the volume of a rectangular solid? Yeah, rectangular solid. You got to like that. Who remembers the volume formula for a rectangular solid? How did we calculate the volume?
Length times width times height.
Exactly. I love it. And if you think, now real quick, just go with me for a minute. I don't know why I'm going to draw my own picture here when I have one over there, but I've already started, so I'm just going to finish. There we go. And then I'm going to do this. This is kind of neat. Is everybody cool with what's happening there? Do you guys remember, gosh, what do you run into now that's like rectangular? There were these things called records. Do you guys know that? And they had a record player. Is there any vinyl? Anybody out there like vinyl? They have any vinyl collection? No? 8 tracks? No, I'm joking. All right. So the bottom of this stack, let's say this is a stack of records. The bottom of the stack looks like a rectangle. So length, width. The area, now stay with me, please. The area of the bottom would just be length times width. Is that cool? Because it's just a freaking rectangle. We know that. Well, how many do I have stacked up here would be the height. So if I do the area of one of them times how many are stacked up, of course I'm going to get the volume that they occupy. I really want that to make sense. You start stacking records. If you find the area of one of them, multiply by how many are stacked, you're going to get the total volume that goes through. So that's another way to think about why this makes sense, is the area of the bottom times the height of the stack. I don't know if that makes any sense, but I just want to give you another way to look at that formula and why it makes sense.
Jeff,
Yes.
is that for one side? Is that just one side when you're figuring out per length?
Now be careful. This here represents volume. So that would be the entire holding capacity, right? That's how much this could be filled with, right? So I'm not sure. That's not just one side. This would be the bottom, right? In this case, yeah. That's the area of just the bottom. But when I multiply by the height, I fill this whole thing up, which is what volume is. It's how much could fill up a space.
Okay.
Okay, I like it. So I'm going a little bit further than we need to, but I like to give you multiple ways to look at why a formula makes sense. Go ahead,
so it says, did you get it? And where you have figured
the... Let's go down there. Let's take a look. I'm going to erase this stuff I've done here, all the scribble.
Yes. So it says, find the area of one figure and the volume of the other figure.
Yeah, exactly. I love it. So here we go. Which one of these, A or B, would be an area problem?
Would be the problem because it's not a dimensional. I mean,
because it's not 3-dimensional. Yes, I like it.
All right.
So take a minute. Everybody take a minute. Do you have another question, Sal? What's up? So this one is the area we want to do, and this one is the volume. So everybody just take a minute and calculate the volume and the area of those two things. I'll sit here and watch you.
All right. Jeez. So I can't give you the answer quite yet, right? You have to wait till everybody's done.
That's right. All right. So can somebody tell me what would the formula look like for this?
I'll tell you. So if we do the width times height, we have 2 centimeters and 2 centimeters on the height. So that's 4,
let's
right?
Let's slow down. What's the complete formula for volume?
Length times width times height.
And real quick, what units are here?
We have two 2 millimeters. Is
No,
that
no, no.
or
Millimeters would be mm. This is just meters.
meters? Okay, 2 meters.
So what's the length?
The length is 9 meters. I'm sorry.
Length is 9. What's the width?
The width is 2 meters. The height is 2 meters.
Good. And if I put little, you don't normally have to put the units in, but if I put the units in, you can see why it becomes what it does. 9 times 2 times 2 is?
18 and 20? No, 18 times. So 9 times 2.
36.
Good. Yeah, 9 times 2 is 18 times another 2 is 36 watts.
Thanks,
Meters.
thanks, Linnell.
Mm-hmm.
All right.
Meters.
36
Meters.
No. Because what's meter times meter times meter?
Cubic meters.
I like it. So volume always has to be in cubic units unless I use something like gallons, which we created specifically for volume. But 1 gallon is so many cubic meters. It's just kind of a quicker way to say things. But when I'm measuring side lengths with something, the volume will end up being that cubed because it is that times that times that. And of course,
Yep.
area coming
go
down
ahead.
here. Area is just length times width, so I just get 7 yards times 2.5 yards. So I know the units are going to be what?
Yards.
No?
Squared.
Because I can break a pencil.
And then whatever the hell 7 times 2.5 is.
Who cares?
17.5.
Okay, I like it.
Jeff,
Yes.
why is your answer for 36 meters to the third power 3 if
So let
because
me write this a little bit. Let me write
oh
this
I
a
see
little
now. Yes, I see now. Because we're
Yeah. M times M times M is M cubed.
is the m cube could be more than 3 depending on the shape.
Oh,
Can me
think about it. Now, this is a really interesting question.
Mhm.
Now, if I have just a line, that could be like meters. If I have a little area, a little rectangle, that would be meters squared. If I have a little rectangular solid area, look at that. I did that so quick. That would be cubic meters, right? Now don't think about this a lot. This is beyond anything we have to worry about. What the shit would the next level up be?
I don't know.
It would be meter to the 4th, but what would that mean physically? Nothing. We only live in how many dimensions?
3.
That we can experience. Let me say that. 3. And that's all I'll say. I'm not going to freak you guys out with the fact that there's probably 11 dimensions, but don't worry about it. There's only 3 that we physically experience. So beyond this, I couldn't draw a picture of it.
And you don't think you can get to the other dimensions?
All right, let's not go there. That's not
All right.
the point. If you are interested, you can look up something called
You don't want to explore that?
Yes, but not now. There's not a time.
Jeff, I'm still confused right now. Just one on
Sure.
the third shape that you draw from the line to the rectangle to the cubical square on top, where you said, did you get it? On the third on the third shape, the cube that you created, we have 3 meters. That's gonna be 3 sides that were
You have cubic meters. You have meter cubed.
meter cubes.
Yep.
So
And it is. Yeah, go ahead.
you go ahead and then I'll go ahead.
So it is because of the dimensions. I mean, if you realize, so I've shown you several different ways. You can look at multiplying meter times meter times meter. You can think about the fact that it's filled with little cubic, let me see, I can't even draw. There's no way that I'm going to do this.
No,
But yeah, there's a little cubic meter right there. And so how many little cubes could I put into this? I could put 36 of them. Little cubic meters would fit in there, right? But
answer my question.
now you can just break it down. This is 1 dimension, first power, 2 dimensions, second power, 3 dimensions, third power. That's why the next one up is beyond something we can envision because we only know 3 dimensions.
All right. And you answer my question at the same time. And I guess I don't have to calculate the other side just because I'm doing this is
What other
the
side?
not well in my head like I was making it harder because I figured I was counting one since it's a dimensional cube. I was counting the front, the visual
Oh,
sides, and then the back
stop,
times
stop,
two.
stop, stop. That would be called surface area.
Surface area.
Yeah. So real quick, just because you brought it up, and then we're going to move on. I want to show you something because I love that question. It's a good question to ask. I understand why it's confusing, so don't worry. I'm with you. Because sometimes you're like, why do we only have to worry about these three? It looks like it only takes care of a couple of sides. But if I wanted to do surface area, now stay with me. What's the area of this face? What's the dimensions of that face?
4 meters squared.
Yeah, so it's 2 by 2. So this area would be 4 square meters. So I could do that for every face and figure out what's called the surface area is, right? How much area is there across the surface of this object? That has very little to do with the volume of it. So to do the volume, it seems like when I do 9 times 2, that's really just getting, let's just say this face, since I can see it. 9 times 2 is this face, right? But then when I multiply by another 2, I am taking that shape and I am pushing it through the whole volume. That's why I end up with the whole thing. 2 times 9 gives me this face times 2. It's kind of like going through to the back end, so I don't leave anything out when I multiply by that last 2. So I don't know if that helps you, Sal. It's
So
not a bad question. It's a little freaky.
yeah. So
Okay. So don't overthink it. It's really
all
easy
right.
to get overthinking. But the nice thing is we have these formulas if I have these shapes. Of course, different shapes will have different formulas.
Well, we found the volume. I understand that now. Now,
Okay, good.
with the yards, with the area.
Yes.
Well, I'm sure the whole class is learning, so I'm not sure if I should leave any other questions for the class.
Well, any question you ask is going to help somebody out. So is your
Okay.
problem with why that's there or something, or what's the issue?
So area is different from
Volume,
area only has area length and width.
2 dimensions.
Two
That's right.
dimensions.
That's why the units end up squared.
Okay.
Question, Jeff. Oh,
Yes.
were you through? Excuse me, Sal. Were you through?
No, I'm done, sir.
Oh, yeah, because I was kind of looking at that too. I had that, but so it would like for me, like area length is square, that's like 2.
Sure.
Length, width, and height, that's 3, so that's cube.
Exactly. That's what I was
So
talking
I
about
can
up
really
there.
count the formula, help me understand what I'm dealing with.
Multiple ways to see why we end up with powers on our units. The most direct reason is because meter times meter times meter is freaking meter cubed, right? That's the most direct in your
Cube,
face.
yeah.
But then you
Yes.
got 1 dimension, 2 dimensions, 3 dimensions, and that matches up
Right.
with the power also. So there's multiple ways to see
I see.
why the powers are the way they are. I like it.
Thank you.
So I'm going to clear all this chicken scratch.
All right.
Go away. Okay. Now, oh, good. I was about to talk about that. That kicks so much ass. I was worried if I brought that up too early, but it's right here. Let's see. Yeah, I mean, this one is no big deal. Let me see. It's got a big old story behind it, but it's a painting that's rectangular. So if I wanted to figure out the area, what would I do? Area of this painting.
Well, prior to our last math, we're supposed to multiply 24 and 32.
Yeah. So it
And
doesn't
then-
matter what situation I'm in. If I have a rectangular shape, it would be length times width, and it doesn't really matter what order you put them in. Right? So whatever the hell 32 times 24 is.
And
And
we would put, do we have to put
is that 768? Somebody doing that for me?
768? Yeah.
Inch is what? What's the
Inches
unit?
to the second power.
Second power. Okay, I like it.
And that's it. That's our answer.
Yeah. And then just kind of go over what we already talked about earlier. What I'm really excited about is this shape down here. And I want to show you something really, really cool that not very many students get to see. Let me clear this. All right. Wait, how are you able to do that? Okay. So this shape is a cylinder. And the idea I just discussed earlier about the area of the base, what does the base look like?
A circle.
Circle. All right. So I'm going to take a quick little sidestep here. I'm going to show you where the formula comes from. Do you guys see the formula for that shape? Does anything in that formula look familiar to you related to parts of the shape?
Pi r squared.
Yeah. Pi r squared. Now let me do this real quick. If you don't get this, it's okay, but this is so cool. Why the shit is the area of a circle pi r squared? All right, now watch this. This is, you don't have to get this. I'm going to do this a little bit quickly because it's nothing you ever have to do also. I'm just going to do this. If you have questions, you can ask me in office hours or something. So here's a circle. Pretend like that's a circle. And then where's the radius? Sorry. What's up?
I said, that's a pie.
That's a pi. Yeah, I'm sorry. That's trying to be a pi. Poor little thing. Where's the radius? What's the radius mean? It's from the what to the what?
From the center to the edge of the circle.
Yes, from the center out, right? So now it looks like a little. All right. So now watch this. If I do this all the way across, what is that now?
Diameter.
Diameter. So diameter is, of course, 2 radiuses, right? 2 radii. Let me stop. Shouldn't be anything too amazing yet. So does somebody remember the circumference of the circle?
2 pi r.
Yeah, and I want to tell you real quick, there's so many side notes. I'm really sorry. I'm just going to go a little bit quickly. Where the shit did pi come from? It came from the fact that no matter how big of a circle or small of a circle you make, when you take the perimeter, which we call a circumference for a circle, when you take the distance around it, divided by its diameter, you always get the same number. So the Egyptians had a estimate for this. I think their estimate was like 22 sevenths. If you do 22 divided by 7, you almost get pi. And then all these other civilizations had other estimates for it. It was thought to be given by the gods because imagine being an ancient civilization, and if you have a circle like that and you divide the perimeter divided by the diameter, and then you have this circle like that, you do the same thing, divide the perimeter by the diameter, and then you have the earth, and you divide the perimeter by the diameter, perimeter circumference, and you always get the same number. Wouldn't that freak you out just a little bit? So that's why this got its own symbol. There's a few other reasons too, but this is the basic reason why it got its own symbol, because no matter how big the circle is or how small, when you divide those, you get the same number. That is exceptionally freaky. That's why we gave it its own symbol. Has anyone ever been explained that before? Does that sound familiar? That's really good to know though, right? You see pi all over the place. It didn't take me that long to explain it to you. Anyway, so the circumference is 2 pi r because d is 2r. So d times pi is
Jeff.
2r. Yes, sir.
Before we move on, so you're talking about how the earth is by that diameter, right? Wouldn't it freak you out to know what the other dimensions are functioning as a diameter? Like, what is the diameter in the other dimensions that we're not able to be in?
Oh, whoa, dude. Reel it back in. Reel it way back in.
All right, that's a dumb question.
No, it's not. It's just beyond the scope of this class.
All right.
I'm not sure exactly what what you mean, but we're not going to get into other dimensions. Okay.
All right.
So now watch this. I've really not given myself enough room to do this. Let me see. I need more room. Let me erase this big thing over here.
So just to clarify with you, when it comes to shapes, damn it.
What's up?
When it comes to calculating damn.
Hold on to it. Hold on to
Okay.
it. Let me just
All right.
finish this.
Yeah.
So now watch. So this is the diameter. If I start cutting, just stay with me. Stay with me. You don't have to fully get this. I just want to throw this in your head, and please let me finish. How long are each of these?
Radius.
Radius.
Yeah, they're all R long, right? All of them are R, all, because I'm going from the center out. And I cut out, but I don't cut through. So if I don't cut through, I could pick that up and open it like this. So if I pick the top part up and I open it, it's going to look something like this. Give me a little, creative license there, right? Can you imagine just if I cut through here and then I cut but not through the edge, cut but not through the edge, cut but not through the edge, and then I open it, it's going to look like this. Is that cool? So now this is really cool. And again, you don't have to fully get this. So how far is this? If I only go from here to here, because that's going to be this length, isn't it? This length here is me opening this up. I just pick it up and I open it up. So this length is going to be whatever hell that is. And isn't that just half of this? Isn't that just half around the circle? So this length will be pi r. Now let me do the same thing on the bottom. I'll do the same thing on the bottom. I'll open it up, and then I'm gonna fit it in right here. I'm gonna fit it in right here. Put those teeth together. Now how tall is this?
Radius.
Yeah, so what's the area of the rectangle I've made now? Pi r times r. Pi r squared. All right, I'm not going to go over that again. If you don't understand it, it's okay. I just want to show you that at least once in your life. Has anyone ever seen that before? Anyone ever seen that before?
Totally explained what, yeah. I haven't seen it, but
Yeah.
totally explained it.
It's one of my favorites. There's other ways to do it, but this is one of my favorites because there's actually a whole branch of math where if you don't know the area of something, you chop it up and put it into a shape you know. That's exactly what this is. I'm chopping a circle up and putting it into a rectangle. Because I know the area of a rectangle. Anyway, that's enough of that. Sorry, that was a complete aside. This will never show up on any test or anything, which is how learning happens, kids. Not
But
everything has.
Jeff, that's
Yes.
why you're showing us, because you're giving us the
Story behind it, yes. I
you're
like
giving
doing
us a story behind it. Yes, thank you for that. But you're also giving us why it calculates what it calculates
that. Exactly. Okay.
in centimeters
Yes. So
and meters. I'm sorry.
this shape right here. Let me just do it generally. I'm not going to use the numbers they gave me yet. This is the radius. What's the area of this? Of course, that would be pi r squared, right? And how many of those do I have stacked up? Would be h. So how do we get the volume? I would do pi r squared times h, which is what the volume is of a cylinder. So it's the circle at the bottom, and then I multiply by the height. So I move through the whole volume, and then pi r squared h, that's going to be, it's just like length times width times height. It's the exact same idea. Is that all right? You guys all right? Is that too much? So then this one, they give me the dimensions I need. So let's see, volume will be pi times what goes here?
Radius.
Yeah, the radius, which is
5.
R.
what happened to you? 5 what?
Meters.
Meters. And you have to, I don't know why they gave me, I think they gave me 4 spots because they want me to write 5 meters twice. Fine, right? Because it's squared. Is that cool? Pi times r squared, so r times height.
9 meters.
Cool. So you can see the meter is going to make it cubic meters like volume is supposed to be. And let's not worried about pi at the moment. What's 5 times 5 times 9?
90. I mean, no.
225.
225, right? 225, and let me throw pi in there. I just haven't multiplied by pi yet. Let me stop for, is that 225 pi? Because I'm not going to bring pi in yet. No, what happened? Everybody all right? Okay, all right. Now, what is pi, roughly?
3.14.
3.14. On the calculator you guys have, do you have a pi button? If you do, it's better to use that because this is rounded like forever. It's actually 3141596, blah, blah, I think it is. I don't really have too much of it memorized, thank God. So let's see, if I multiply 225 times pi in my calculator, here I'll do it too. My physical calculator is out of battery, which really sucks. I gotta find the charger for it, but let me use my virtual calculator.
Can I ask one thing? Like,
Sure.
before, so when you're, if we have some other shape of the, where you're showing us that sphere, or what is this called? This shape right here that we have on the right?
I can't do what I want to do. Sorry, say again.
I guess my question is, when you're figuring out the, I don't know what that's called. Let's say the circle shape on the, what do you call that on the bottom of that shape? That side, what is that called?
What, the circle?
Yeah.
Okay.
So
What?
you're showing us how to figure out the length, right? The total meters of it. So you
No, wait,
break it.
no, I don't understand. No, there's no, all right, I'm not sure. So we find the area of the circle. That's the pi r squared part, right?
Okay.
And then I
But
multiply by
okay, in any case, are we gonna be able? Are we gonna? In any point, are we gonna run into a question that's gonna ask us to find the radius of the circle? Like the way you
You're
show us.
worrying way too much. You're worrying
Okay.
way too much. They
All right.
have to give me the radius if I have a formula. Yeah, I think we're not going to suddenly become a geometry class. Don't freak out too much.
All right.
We're going to have formulas that we can use. They're going to have to tell me enough information.
Okay. This
yeah.
is good. I get it though. I understand what you wrote. And it's just applying it once I see those tests on those questions on the test. So
So this is what I get when I use the pi button in my calculator. Did anyone else try that? Okay. Is that right? So I know all this stuff up here. I'm sorry if that took you off track. I just want to show you. But all we're doing is we have a formula. We know the radius and the height, so we just have to plug those into the formula. And then the other thing was the pi. If you don't have a pi button, you can use 3.14 as an estimate. It's just your answer is gonna be a little bit off.
why
Okay.
why is that?
Because pi is not equal to 3.14.
Pi is equal to 3.1415.
Forever.
Forever?
Hell yeah. Yes. All right. So the other thing about pi, the reason we give it a symbol is because it's what's called an irrational number. It has no pattern and this never ends. There are people that have memorized 50,000 places of pi. Don't ask me why. They'll die. So I don't know. There's better things to do with your time. So anyway, I'm gonna clear all that.
But Jeff, hold on.
Yes. That's why I'm asking before I do it.
I guess it's not important to screenshot most of your notes, but since this one has that one thing that I want to.
Sure. Ow,
Wait, hold on. Hold on.
killing me.
All right. We can move on. My bad.
So, I mean, down here, they're really just hammering it in your head how multiplication of units works. So these should be relatively simple, I'm hoping, right? So for example, this one is going to end up with what units? What is this going to be? It's just what?
Meters squared.
Meters.
Yes, 24 square meters, 24 meters squared. I like it. So this whole section here should be kind of old news to us. This one, oh, holy crap, I got a bunch of chats. I'm sorry. That's from 3 minutes ago.
Jeff.
Cylinder jinx. I love it. What's up?
Question number 9, and the gentleman said that it's meters, right? So we do 6 times 4 meters is 24 to the meter to the second power.
Yep, that's it. Yep, because m times m is m squared. That's all.
All right. All right. Now, question number 11 looks a little bit more like it's not complicated, but when
Well,
you
it
don't
is.
know when you don't know the formula, then anything is going to be
No,
complicated.
we don't have to know the formula. There's nothing. I just have to do what they've given me. So let me write 4 pi. What happens here?
So we have 4 pi, and then we have 4 inches to the third power. It's more like in a
Yes, what do
fraction.
I have to cube? What do I cube?
We're gonna times 4 inches times itself 3 times.
Yes, I like it. So 4 cubed times cubic inches. So I just did one thing. I just cubed both of those things in there. So you know what 4 cubed is?
It's gonna be 4 times 2 is 8. Then
Stop
8
at the
times.
twos. No, stop at the 2. 3 fours. 4 times 4 times 4.
Well, I don't know my timetables, and that's a start.
Mm.
So it's 12.
16 times 4.
64.
64. And then I'll do
What?
this one. What?
Okay, hold on. Why
So
is
all
it
you gotta-
64?
All right. You cool with 4 times 4 is 16.
Okay.
Yeah, and then 16 times 4, 64.
All right.
So you got to multiply 3 fourths together. So that grows pretty quickly.
Yes, that's good.
And then I got to multiply by another 4. And to multiply by 4, I could just double something twice.
64 times 4.
Now listen to what I'm saying. To multiply by 4, I can double something twice. Does that make sense? If I double something twice, I'm multiplying by 4 overall. So if I double 64, I get 128. And if I double 128, I get 256. And that would be a place I'd stop. But then you could plug all this shit in the calculator and get some decimal. Okay, let me stop for a minute.
Okay.
So all I really had to do on this problem was this piece right here where I had to cube the 4 and the inches. This formula, this is an actual formula. This is the formula for the area, I'm sorry, for the volume of a sphere. And I draw a sphere like this. A little. So this is the volume of a sphere. Sphere.
Sphere.
Yes. You can do it like that also. So if I know the radius, that's all I need to know. And then I can figure out the volume of that whole sphere. I like it. Okay. So
Wait.
let me, yes.
So we always have to. Let me just read question number. What the heck? I ignored you towards the end when you found the volume?
Well, that's never a good idea. Never a good idea to do that, and then never a good idea to admit that. But what's the matter?
Can you give? So I know how to get the answer of 256, and I all right, Jeff. So can you, I left off when you got the answer for 256 over 3 and inches to the third power. So how
So
would
what's
you,
so
the
we
problem
got
is that I don't know how to calculate now the 4 over 3, your volume. The answer on the left that you wrote.
all right. Stop. So up on the top, on the top. You're cool with this piece, right?
Yeah.
Okay.
No,
So
I'm
one
not cool with that piece.
all right. So that's you got to go back to where you lost coolness. So let me erase some of this. All right. So right here, what does that mean? That means I have to cube the 4 and cube the inches.
We just did that.
Okay. So that's what I was asking you. Are you cool with this piece right here?
Yes.
Yes, you are. You just said you weren't, but you are. Okay. Then we do 4 cubed, and we know that's 64. And then I multiplied by 4 again, and I got 256. So I'm just doing everything the top tells me to do. What's 4 times 4 cubed? 256
256.
times pi times cubic inches.
Yes.
So that's the top, and the bottom is just a plain old 3.
Okay.
And then if you throw that in the calculator, 256 times pi divided by 3, you'll get a decimal. I actually don't care. That's just you throw it in the calculator. Right? You can throw that in the calculator, get a decimal, whoop-de-doo, right? So that part is nothing that we have to worry about. We just throw in the calculator.
How do you get the decimal? You divide it by 3?
All right, so you have to do 256 times pi. That's what it says to do on the top, and then you have to divide by 3. And that would make, yeah, because that's what it says to do, right? It says 256 times pi divided by 3. So if I put that in the calculator, I would get the decimal.
Well, I did the 256 times 3 and it gives me 768 and then divided by 3.
Wait a minute. Why did you multiply by 3?
Because I don't know any better. So
Pi is not 3. The thing I would let you do is to say pi is roughly 3.14. That would be okay, but you can't use 3. That's rounded way too much.
Jeff, how do you get the decimal? What?
All right. I'm going to stop sharing this.
Okay. All right. I think I can just.
Hold on. Just let me do something.
All right. Sir.
Where are you? There you are. Okay.
I'm learning. I'm getting your point. I'm just confused on getting the actual answer for your volume.
All right. So this might not look like your calculator, which is fine. I'm hoping you guys have at least a scientific calculator, if not a TI.
Scientific.
Scientific calculator. They
All right,
cost
sir.
about $15. And scientific calculators, all that means is as you plug stuff in, you see everything you're plugging in. The old little tiny calculators where you plug a number in, then you hit times, and then that number disappears as you plug in more shit. That's not good. So 256 times, I have a pi button right there. So by 256 times pi divided by 3, and there's the decimal, all right?
Yeah, this calculator. This calculator.
Or if I do 256 times 3.14 as an approximation, watch, I'm not going to get the exact, see how I didn't get the exact right answer, but it's only off a little bit. That's why 3.14 is acceptable in most things. It doesn't really make it too far off.
And they don't. I mean, it's dumb to ask, but I'm gonna go ahead and ask it.
Sure.
Why does pi give you a decimal? Like, is that how? Nah, never mind. I'll just stick to the topic so I can get this exam passed.
Why did we give pi a symbol? Like I said earlier, we gave it a symbol because it comes out to be a decimal that never ends. So instead of trying to write the whole number, which would take the rest of my life and my kids' lives and so forth, we just gave it a little symbol, pi. Yeah.
And it wouldn't be smart to call interest rates like a pi, right? Because because it carries a decimal. And
I wouldn't say it wouldn't be smart. I'm just saying it wouldn't be something we normally do. Yeah.
Yeah.
Okay. Let me see. Oh, cool.
it's cool.
All right, let's see. Let me find you guys a decent little problem here. Yeah, look at this. Oh, all right. Look at this problem. I almost don't want to show you this problem, and I'm going to. This formula right there, it shouldn't exist. What is that formula finding for this triangle?
Pi equals a.
Stop,
Well,
stop,
it's
stop, 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 stop.
The parameter.
Perimeter. There you go. That's what that formula is finding. I didn't want you to read it to me. Just what is it finding? And it tells you right there. It finds the perimeter. I think I've said this before, but maybe not. We never really need perimeter formulas because the idea is so simple. You just add up all the side lengths. So I don't want to make a perimeter formula for every shape. That wouldn't make any sense. I don't need it because all I have to do is add up all the side lengths, right? And let's see. It says the length of each side is measured in inches. So take a minute, don't say anything. Figure out the perimeter real quick and put the units on it.
Hey, Jeff.
Yes.
And sometimes I've seen like in this lesson, in some of the lessons, it has shown find the perimeter for one side, right? And let's
No, that
say
doesn't make any sense. You can't have a perimeter of one side.
no, find the length in a perimeter, and it's
Are you talking about a problem that they tell you this is 5 and this is 2, and they say the perimeter is 17?
Fine.
And they say, what's
Yeah.
this side?
Yeah. So I
Right.
guess, yeah, so we subtract, I guess that's obvious.
Yeah, 5 plus 2 is 7. So what's this side got to be to make 17? So
All right.
that is a possible problem they could give you, but it's just, you use the exact same, you have to add all the sides. So you just have to figure out that last side has to be 10. So overall you get 17, yeah. So what are you guys getting for this?
$30x inches.
Yeah, 30x inches. Is everybody cool with the fact that, I mean, I'm adding these, right? And this is perimeter. Perimeter is one dimension. It just goes in one dimension. It's not area. It doesn't cover something. So it's going to be just plain old inches. And I'm adding, so the power is not going to suddenly become squared or cubed. That's only if I'm multiplying. Okay, all right. So I just wanted to make that point right now. You got to be really careful. You only go squared, cubed if I'm multiplying stuff. Okay. So I'm going to clear that. Oh, let me see. Oh, okay. Let me put this up here with the picture. So the next problem asks you this. It says find the area. And does this formula look familiar? So this is problem number 11. It says find the area of this triangle. Does that formula look familiar? And of course, that formula makes all the sense in the world because if I have this parallelogram, the area is base times height, and a triangle would be half of that. So that formula makes complete sense. So what is the base? And what's the height?
12x and 5x.
Yeah, 12x is the base and 5x is the height. And now, of course, I'm going to have some other powers come into play. So half of 12 is 6 times 5 is 30. X times x
X squared.
squared. And the units were inches on everything, right? So this is going to end up being what units?
Inches squared.
Yeah, square inches for area. I love it. Okay, so perimeter formulas always involve addition because you want to add up all the sides. area and volume are going to involve multiplication somehow. And that's why you get higher degrees. That's why you get squares and cubes. Okay. I'm going to clear that. Go away. Blah, 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 blah. All right, so let's take a little quick peek at what the homework is actually going to look like. So here they give you a problem like we did earlier. You just got to throw this bad boy. Now look, without doing any calculations. So this is why some of you guys, very often you don't read what it wants you to do and you start doing all this weird shit and it doesn't even want you to do it. So this volume is supposed to find the volume of the empty space in a can of tennis balls. So that kind of makes sense. That's a little bit complicated because you have to take into account the volume of the balls and the volume of the thing, and you got to subtract them and all that kind of stuff. Do you have to really worry about where that formula came from? No, but it does kind of make sense that it's involving subtraction and all that kind of stuff. But explain how you can tell that the answer will be wrong. This is good. I like it. Oh, this is nifty. Okay. So watch. What would the units end up being here on this first piece?
Centimeters, not cubic.
I'm sorry. This first piece will end up being centimeters, what? Centimeters to the cubed, right? Squared times another one is cubed. Is that all right? I don't know why I'm doing this problem for you. And of course, this one is going to be
Cubed also.
how do you get cubed? I've got centimeter squared, but there's no other centimeter to make it cubed. Do you see that? This one right here, it's centimeter squared, and there's no other centimeter to make it cubed. So is this one really a volume formula? Did they write this problem right? This would be like an area. It's only got square units. Okay. So that's why they tell you that the units in like terms might come into play. These aren't even like terms. This is centimeter cubed and this is centimeter squared. I couldn't even put those together. All right, so that one is okay because that was a little bit weird. Oh yeah, I told you. Well, anyway, I'm gonna let you.
Yeah.
Yes.
So what are you telling us in question 1? What's going on?
Everything I just said. So this first piece, since I basically did it, let me make sure you guys get this. Right, if I just look at the units, I don't care about the numbers right now. That's centimeter squared, right? Centimeter squared with some number, I don't care about the number, times centimeter. So what's that end up being at the end? Cubic centimeters. Is that cool? No, you guys all hate that. What's happening? So right here, don't I get square centimeters?
Yes.
And when I multiply by another centimeter, I get cubic centimeters.
Then you get cubed.
You get 3
so you got-
centimeters.
So this guy only ends up with square centimeters. So I don't know if you guys were paying attention earlier that this looks like it wants to be the volume of a sphere, except it's supposed to have a cube here. That's the mistake they made. And then the units would match, right? If I put a cube here instead of a squared, then the units would match. So somebody just put the wrong power on there.
Right.
Okay. So that's the thing that we've been building up to, is this whole idea of making sure you got the right units so that you can put everything together you're supposed to. This problem, they didn't write it correctly. There's not the correct unit. So you can tell immediately it's not going to work. The units don't match. Okay.
I got confused because at the top it says the radius of a tennis ball is 3.3 centimeters. So I thought they just calculated 2 when they put the cube and it's 3 balls in this thing, in this container.
So the problem here is in this piece, I can only get square centimeters if I work this out. Right? Over here, I get square centimeters, and then there's another centimeter, which makes it cubic. But over here, there's nothing that makes this part cubic. It can't be a volume. They wrote it wrong. Yeah, that's why that's supposed to be a third power, because that's the formula for a sphere. Aren't these spheres?
Yes.
Yes. So they should be third power right there because there are 3 spheres. So this really should be the volume of a sphere, which has a cube on it so that it becomes volume. Okay. So
Jeff,
yes.
what do you do with the 3.3 centimeter? Like when you're dealing with, when you see, I get your point on how you're breaking it down and finding the answer for the volume, but what happens to 3.3 centimeters? Like,
On this
why
first
does
problem,
that disappear?
on this, it didn't disappear. On this first problem, all I care about are the units. The only question they asked me is, without doing any calculations, how can you tell that this won't come up with the right answer? And then they gave me big hints, the units and like terms. Well, these units are cubic centimeters and these units are square centimeters. I can never put those together. And square centimeters don't represent a volume. So how could this whole thing represent a volume? It can't, because this piece has square centimeters.
Right.
So that's why I'm not worried about the numbers. Number 3, you're going to worry about the numbers. I'm going to let you guys do that one.
Huh. All right. Well, that's good.
Yeah. I'm going to clear this. All right. Just a couple more here, and then I'm going to let us out. Let's see. Blah, 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 blah.
Do you have office hours today after
Yeah, I got my 12:30 to 1:30, I think, today. Yeah.
12:30, 1:30?
So they're going to give you a bunch of, they're going to give you some information. They're going to ask you to figure out the volume of several things. So it's going to be really important. If I were you, I would write down the formulas they gave us. Let me see if they summarize it. No. So the formulas they gave us in this section, so I can use them in the homework. For example, that sphere one seems to be coming in really handy. So you're going to have to use that 4/3 pi r cubed thing in a few different places. Okay. Let me write that down real quick. So sphere volume. I like it. Right, and then some of the other ones we already know. Okay. So as you go through the homework, and if you hit a problem that it wants you to figure out the volume and you're not sure what the formula is, you can look back through the section, or you can email me, or you can Google it, right? Google is our friend if we know how to use it correctly. If your Google foo is good. All right, let me clear that. Okay, but the main focus of the section really is just, why does it make sense what the units are for all the various dimensions, the perimeter, area, volume, right? And we talked a little bit about higher dimensions. I didn't want to talk too much about that. All right, last thing, let me see, what time is it? Yeah, we can leave a little early today, I think. I want to look ahead at what's coming up. So it looks like the next section is going to have some fraction stuff. Oh, yeah. And we're going to get into some conversion stuff. So I'm not going to make you memorize all of these, but some of these you should know. So it looks like the next section is going to continue this idea of physical measurements. And we're going to talk about how to convert between types of measurements. Oh, crap. So let's see what the next section, there we go. Convert units. And then we're going to talk about the metric system. Oh shit, we're the only country on the face of the earth that does not use metric system. There used to be 3 of us and the other 2 have voted it in. So we are the only country left that does not use metric. Anyway, I'll stop. All right, so that's something to look forward to. Is next section we're going to talk about conversions between things. Like conversion between Celsius and Fahrenheit. That actually came up in a homework problem. conversion between centimeters and inches, all that kind of stuff. Okay, that's enough for today, I think.
Right. And 12:30 today, right?
12:30 if you want to, yeah.
I got some homework. Well, this specifically right now, it's my main focus because of the quiz. But I'm gonna go ahead and work on that. And any questions I do arise, I'll see you at 12:30.
Okay, so anybody
thanks.
wants to, the link is in Canvas under the extra alpha module. Let me know if you have any questions if you want to hang around for a bit.
I just wanted to say sorry for being late. I had a doctor's appointment.
Understood.
Thank you. Bye.
All right, is everybody good? I'm gonna head out. I don't have any questions. All right, I'll see you guys.